Hello everyone, hope you all are doing well. So now we will start our new topic, that is Planck's quantum theory. So talking about Planck's quantum theory, firstly we should know that what quantum is. So I am writing here two words, one is quanta and quantum. The quanta is a plural word, and the singular of the quanta is quantum. Okay, the singular of quanta is quantum. So let's move further to know about the quantum, that what quantum is actual. So we'll write here quantum. Quantum, actually you can say the packets of energy. You can also say the packet of energy waves, or we can say the energy waves packets. Okay, so after that, let's move further. That packets of energy, they are the two ideas about the energy waves. So we will discuss that two ideas about energy waves. The two ideas of energy wave, the first one is called old, or you can say classical idea. Okay, and secondly we were having the modern modern idea of, you can say, energy wave, quantum, or whatever. So there are the many words that we can use in the place of this. Okay, so firstly we will talk about the old or classical idea. In old or classical idea, we are using macroscopic level radiations. I am writing here macroscopic level. In macroscopic level, what happens, we are having continuous emission, like the old ideas, like the old people of this idea, the Planck's quantum theory said that energy waves is a macroscopic level particle and having continuous, you can say, a continuous emission of energy waves. Okay, but talking about modern idea of energy wave, yeah, quantum idea, in this one, this idea was given by Planck's constant, because he was also modern, but he have given the microscopic idea of quantum, or you can also say energy level. He said that it's not a continuous, it's a continuous it's a discontinuous emission of energy. Okay, but how we know? So we will make a diagram first to know about the continuous emission and discontinuous emission, that what these both are. So talking about continuous emission, like this is, we are having ground surface. Okay, in this ground surface we are having any energy over here. Okay, when it moves upward, okay, and it's stopped there, so we are having one that is called the potential energy, and second we are having kinetic energy. So here we are having different points, wait, okay, like 0, 1, 2, 3, 4, and from here opposite 0, 1, 2, 3, and 4. Likewise, from ground to upward, the potential energy, what potential energy increases. Like previously we are having low energy level, when it far away from the ground it's having more energy level. Okay, but on the other side we are having the decreasing of kinetic energy. Here we are having increasing of energy level, here we are having decreasing of kinetic energy when it will move upward from the ground side, like opposite of the potential energy. Like in potential energy we are having low energy level, when it move upward we are having high energy level, but in kinetic energy we are having high kinetic energy to the near one, means the motion, like we are having K shell over here near to the nucleus, it is having the more motion, when it move the far away it is having low motion. So like that one. Okay, after that move to discontinuous emission. And discontinuous emission, let's suppose, we are having the shells over here. Let me make the shells. Like we are having K, L, M, N, O. These are we are having shells. Here we are having potential energy. Okay, it is unstable now because it's on the last shell. It want to be stable. So what happens that at this one place when it's come downward, like how it's got discontinuous. At this O position, it's a microscopic. Microscopic means very low amount it got stable, means microscopic level. And discontinuous emission, I will also explain discontinuous emission. Discontinuous emission means in uh, old or classical idea we are having continuous emission, means one by one, but in this one we are having discontinuous. Like it will come on O shell first, okay, it will stable just for a microseconds, okay, then it's again move to next, then move to next. So like this one position at the last K position it will got stable. So means in a discontinuous position it got stable but for a very microscopic level. And this stability, the few second stability, is called the meta state. What it called? It called the meta state, means the discontinuous of the emission on the meta state because of the low stability on the orbits, but on the one last orbit it got stable. So it's called the modern idea of energy wave, discontinuous emission of energy wave. So these both are the difference between the old or classical idea and modern idea. Hope you understand today's lecture. Thank you so much for listening.